Hey all, good morning. Thank you so much for joining the session. Let me share my screen. I think the screen is visible. Just give me a minute. This is the meetup group. This is the meetup group which we are hosting the session from. And you can see .NET Learners House. Please subscribe to this for joining the for getting the notification of future events. Okay, and the next thing is all these videos will be streamed here in .NET Learners House YouTube channel. Please subscribe to that. Okay, thank you so much. So let's start. What is that we are going to discuss today? This is my GitHub link. Let me give this so that it will be handy for you people to you people to access the code and demo script. And this is the repository where I'll store all the demo scripts. And today's demo script is here, and it has got the link. It has got the link to the coding also. I mean, where the source code has been stored, you will have access to that link also. Also, I think I'll provide the link here. I'll update it later on this one. I'll provide the link over here too. Okay, so without any further delay, let's start and see what is that we are going to do today. So today's session is how can we do or work with AWS Code Commit, Code Build, and Code Deploy with .NET 8 minimal API. When I was trying this, I have referred quite a few videos and web links. I'll see that I will add it here. I would have added few, but I'll update this by tomorrow. Okay. Right now, if you see that this is a session, and we are going to do these things. Before that, I'm still a learner, far from intermediate, advanced, and expert for sure. I'm just a learner. So apologize if I do any mistake. And please fasten your seatbelt. And here is the repo for the source code. If you click on this, you will see it takes you to this one. This is the code with which we'll be working today. Okay. So I'll minimize this so that I have less number of tabs to deal with. So if you see what is that we are going to do, let me walk you through quickly. We'll speak about the big picture, what is that we are doing, and then we will speak about the .NET 8 minimal API and how do we execute. There are multiple ways to execute. We'll see one of the way, but I have mentioned we can use Swagger, Postman, .http file, curl. There are many ways to do it, but we'll try one way. And we'll also see the logs. And then we'll start with AWS Code Commit. We'll see that what is a repository. And then how do we check in and check out? And what is the importance of the credentials? And we'll speak about the branches and feature branch. Why do we need those things? And the feature development itself and how many commits we can do. That depends upon what is the best thing. Well, we'll speak about some of the best practices and pull request and merging strategies. And then we'll speak about the code deploy. We'll speak about the S3 bucket and the code build project and the build spec file. And before writing the commands, we should verify those commands locally. So that's what we'll be doing. Then we'll inject those commands over here. And then we'll see how to build the repo with .NET 8. And then we'll download the artifacts which the build will generate, and we'll verify that all the things which we wanted to see are they present in the artifact location. Then we'll prepare the EC2. I mean, I already created it just to save time because it might take 5 to 10 minutes in each step. So I already pre-created it last night, so that we can discuss on those topics. We'll touch all these topics step by step. So this is the machine, EC2 instance, and then installing the code deploy agent, one of the link I've given. There are other couple of links I need to add it, but I'll definitely add that. And then we'll see how to install this .NET runtime. These are the commands which we need to execute, and this is given in Microsoft MS Learn module. And this is the AWS Code Deploy. So for that, we need application, deployment group, and individual deployments. So, and then we'll see that how many deployments we did it, and in each deployment step, what all the sub steps kind of thing it does. And we'll see the current demos appspec file. This gives us a lot of information, and also we'll see the appspec file from the AWS itself. And then we'll deploy this to EC2. From the AWS Code Deploy to EC2, we'll do it. And then we will verify the logs also. Okay, now what I'll do is I'll remove myself from the streaming so that you guys will get extra space in viewing. Okay, so let's start with our first steps over here. Let's come back and start with this. We have seen the big picture till now. Okay, so this is the weather API, but we will see that. First is, let's speak about the .NET 8 minimal API. So this is the one which we'll be using for today's demo. Okay, so let me walk you guys through this before we go any further. So here is the code, which is the .NET 8 minimal API. So you can see this is the .NET 8 minimal API template. And you can see that we are using Swagger, Entity Framework Core in memory, and also Serilog and AutoMapper. These are the few things which we are using it in this one. Now, coming back to the API, the program.cs is a file where we are starting our lives, and we are configuring all the dependency services here in this extension method, and all the HTTP request response pipeline has been configured in this extension method. So you can see that there are two extension methods. One extension method is for configuring the services. Like you can see, we are having the AutoMapper, we are having the business logic layer, we are having the repository layer, Swagger, and CORS. I mean, CORS definitely we will need a UI going forward, but at least we have added here right now. So another thing is the second extension method, and we can see that when we are configuring the HTTP request response pipeline, we'll see that within the development environment, we are removing the database and we are recreating. Ensure that it is created. Okay, if the database exists in any table, there will not be any action. If it doesn't, then it goes and creates it. I mean, this is not the way to do it in production. The separate team will have, and we might need to create the database SQL project that's going to come in this month, and I'll be doing a session on .NET 8 and EF Core 8, where I'll show you some of those things. But this is only for us to test it locally. So just put it here. And here, if you see that, Hello World endpoints and course endpoints. There are a couple of endpoints. So when we are working with minimal API, nothing is stopping us from using any architecture or any kind of code practices. Nothing is going to stop us. So similarly, if you see that when we are using full-blown web API, we will have a controllers folder. And similarly, I just created a folder called endpoints and moved all the endpoints, respective endpoints, into its own classes. So you can see that Hello World endpoints, there are 4 endpoints over here. And from the courses perspective, there is one endpoint, that is get all courses. And if you see that this is all-in-one architecture where organization of the code has been done based on the functionality or grouping. So if you see that application core, we have interfaces which will be used across multiple places. At least if you see the business logic layer and the repository layers, they are using these interfaces. And inside the common, if you see that, we have the in-memory database name is school database. That's a constant kind of thing. And here, if you see that Hello World routes is also a constant kind of thing. And also here, the courses routes. All these routes has been moved into a class. Like you see that this is a partial class, but everything comes under the constants. So how are we using these constants? Means if you come to either the Hello World endpoints, we are referring those Hello World endpoints from here. So one of the good feature in .NET 8 is, from .NET 6, I think this is allowed, but I started using more in .NET 8. And 6 also I used to use it to a decent extent, but not to this level. So if you see that the namespace where this has been defined, like if you see school API application core common constant and constants. So if you see school API application core common constants that we included in the CS proj and marked it as a static equal to true. So that means what happens is it will create this inside the global usings. If we go to this obj, if you go to this obj folder, and if you go to that debug, and in here you will see that global usings, and whatever we have declared there inside the CS proj will be added. This is the auto-generated one. So one of the best practices or suggested way is when you want to use these kind of global using statements, better to put those here inside the CS proj. So the framework itself will take care and include or inject while it is creating the automated files. Okay, that's one thing. Now, if you see that we have application core, and now from the perspective of data, we can see that we have entities. We have the base entity or auditable entities, and the course is one entity, and this maps with the database. And the data transfer objects is, we have a couple of things. We are using record, so it is a little bit of performant, and we have course DTO and create course DTO. So when we are creating the object or a row inside the database, we will not give user a chance to add an ID. So it gets auto-created. If you see this here, the ID, the unique identification for each row will be automatically created by this one. And this is a specific one to identify whether it is a student or lecturer or subject, course, anything, book, any of this object its individual identifier is that. And next layer of the data and application core comes the persistent layer. If you see that inside the persistence layer, we have created the school DB context. And one thing you will observe is I'm using the primary constructor. So I'm not having the constructor parameterized constructor here as we used to have it. From .NET 8 onwards, we can use the primary constructor where it helps us to inject the dependencies. We don't need to write an explicit constructor. And seed data is to add some rows. That's what we are doing. So we spoke about the data and we spoke about the persistence and we spoke about the extensions, application core. Who is going to use the persistence? That is being used by the repository. Now, if you see the repository layer, it is lean. And also we are using the primary constructor. Now from the number of lines perspective, you see that it is looks very lean, less than 20 lines, excluding those mustaches and blank lines. Technically, I could have moved this to the CS project where we are using it. So in that case, this will be much lesser. And the next is the business logic layer, where we can write some logic, like we are speaking with the database and it gives us the set of courses, and then we are converting the courses into the API response and giving back to the endpoint. And here in this courses endpoint, if you see that the courses endpoint is just retrieving whatever it needs from the business logic layer and returning it. Let's see this in action at the local before proceeding further. So let me come back to the demo script. We spoke about this, and now we'll see these things. Okay. So here you have the school API. So I added a couple of endpoints here. So let me execute this one. And when I execute it, it comes in here. So one thing we need to understand is the 5264. The 5264 is a port, and the host is, if you come in here, I'm running it in HTTP mode. So that is this one. So host name and the port, we call it as host. And if I come and send a request, it goes and gets hello world minimum API. So if we send this to the root, so we can come in here and test this one. We will see the same output. Okay, now let's see API. So you see this one. Now let me go back to this and hit the API endpoint, click on try it out, and you see the response over here. The same response, similar response. I'm not going to tell same because the timestamp, if you see, is a little bit different. That's the UTC timestamp. It will vary a little bit. If you see that it is 3:48, 20 seconds, and this is 3:48, 30 seconds. We see that it's a little bit different. And now if you see that courses, and if I go and hit it, so it bought the courses in the data object. Now here we can come back to the courses and click on get courses. I can see this has been processed in 3:49, 16 seconds, and this was processed in 3:49, 3 seconds. So there's a gap of at least 10 seconds we hit it. So this is how we will we can verify that all is well and everything is working. And we see these logs when we are executing locally. We'll see the logs also when we deploy it into the EC2. Okay, so that's about our local. So this is the first block which we wanted to discuss, we discussed it. That's the first point. We create a minimal API. We discussed about it, and then we tested it manually, and we saw the logs locally. Now let's come to the AWS code commit. So I will come in here and check that this is the AWS code commit. Let me reorganize this in a way so that we can see everything step by step. So this is the AWS code commit, and whatever we are discussing is this one. So I tested and did some check-ins 10 hours ago. So we'll speak about everything in detail. Okay, so if you come back to the documentation of the demo script, you see that as we create the repositories in any source control, let it be the Bitbucket or GitHub or Azure DevOps, SVN, MKS. Thanks, I had a glass of water. The different source control systems. So similarly, this AWS developer tools, it's the code commit or the code build, code deploy, code pipeline, and code artifacts. All these are very native to AWS. Like if you see the Azure DevOps is very native to Azure. Similarly, for AWS, these are the source control and CI/CD tools. And we explored a couple of sessions. If you see here in this documentation, this session is purely on the code commit, and this session was done on the code build. One difference is the code commit was on .NET 6 or 7, I don't remember exactly. And the code build and Spring Boot Hello World API, both are. And if you see the code build, this session was heavy on Spring Boot side. It wasn't, I didn't get a chance to do it on .NET 8. So whatever I'm doing, this .NET 8 is exclusively, we are doing everything from starting. We saw that how do we create locally, and how can we do it in code commit. We are starting from there. So the first thing is we need to create a repository. So that is what we are seeing here. We came to this. This is the repository. And inside this repository, we can go to a particular repo. This has got set of repositories. Like similarly, any source control will have set of repository. This one will also have that. So if you want to clone, we have to clone it using HTTPS or SSH, HTTPS, GRC, and different modes. They have given 3 modes, but I used the HTTP one. For this to work, we need to create the GitHub's username and password, which will help us in creating, cloning it, and all these things. It will help us. Now, if you see that AWS code commit, so I just created this. So that is what I'm using here. When I'm cloning, you can see that Vishy payload. This one, I'm using it. So it's created, it's pretty old, but you definitely need it if you want to work with this one. So when you clone it for the first time, at the time, definitely it will ask you this credentials. So that you will get it from you have to create it, AWS code commit credentials here, so which we will use it. So this will go and get stored inside the Git credential manager locally. If you want, you can go to the credential manager and get into that generic credentials, and you can delete it, and again it will ask. Now if I do any number of times, it will not ask me. So just now I updated it. So just wanted to git status. So this is the directory where I cloned it. So also whatever the changes which I did it last night, I just bought it and merged to my Swami uh, 2nd Feb, and all is well here. So that's one thing I wanted to discuss. Now, the second thing is branches and feature branch. So this branching strategy is like one of the very important thing as part of our development. We should never allow anyone to check in to the main branch. So generally what we do is we will create generally 4 branches if it works good with the team, or 2 or 3 environments. Based on each environment, we'll have each branches. Okay, main refers to the production, and stage refers to UAT or staging, and test is for QA to test it, and dev is for devs to go ahead and integrate. So those are minimum 4 branches based on 4 environments. If some company or some team, they have only 3 environments, they can have 3 branches. The main branch should always represent the production environment. So anytime there is an hot fix, we need to do it from the main branch. So never ever push anything to main branch until unless everything got tested, certified, UAT done on the stage. Okay, so and whatever we do it should be at the lowest level is on the dev branch. So each of the work item, user story, or the product backlog item, whatever your team calls it, each work item should have a feature branch. That means like there might be a number of developers, like Ali, his task ID and its description, like Swami, his task ID and its description, and Manish is task ID and its description. So each of the developers should have their own feature branch that has been created from the dev branch. Okay, because this is demo, I'm using the main branch, but what we generally do is we'll create a feature branch based on the task or a user story on which we are working, and we create the feature branch and we'll merge it to the dev branch. We'll not merge to test stage or main. We will merge it to the dev branch. And once we test it, all the developers, it's like an integration environment, then we will promote those binaries to the test environment and deploy it to the test environment from the test branch where QAs will certify, and then just before the production, it will promote it to the stage where UAT will do their user acceptance test, and once all is well, it will be pushed to the production. So that's about the branches. Now, if you come back to this AWS environment, here we can see have 2 branches. One branch is main, and another branch is this one, yesterday, whatever I created. Okay. Now, the second point is technically we should have different branches, and this is the feature branch, which is different from this branch, because feature branch is representing a work item, maybe a user story or a task or a bug. It could be anything, but feature branch represents a work. Okay, and dev, test, stage, and main, they represent an environment. Again, I'll tell that. So feature branch always represent a work item. It could be a user story or a task, product backlog item, or a bug, anything. So feature branch represents the work, and dev, test, stage, and main, these represents the environments. Now, coming back to this one, when we are doing the feature development, we can do any number of commits. So you can come back to this commits over here, and you can see the commits for different things, like different branches. You can select the branch and you can see that all the commits we did it. And if you want to see what did we push it in that particular commit, and we can see the details, how many files we have added and how many messages, commit messages we do have it. Okay, and this is the commit visualizer where it graphically shows that how did we progress since past 18 hours. How many times did I check in? So you can see that started 18 hours ago and then did a pull request and merged it, did a squash merge, and again there is a squash merge 13 hours ago. And now we are going to do another squash merge sometime now, definitely. So we can do a compare of the commits. Like if I come in here, source and destination, always we will push our code to the feature branch and then check it, compare it with the dev branch. In this case, we are using main, but always we'll be pushing our code to the dev branches. Okay, right now there are no differences between this one because just now I refreshed everything as you've seen here in the screen. Okay, so that's about the code commits and pull request and merge. So we'll see how to do the pull request just in a minute. So let me come back to this one. I will close everything. So let's not disturb the code. So what we will do is we'll come back to this one and write some message in the README file. Okay. I'll say that this is first test. Okay. I just did that. And now you can see I'm git status, git add, git commit, test1, that's the commit message, and I'm doing git push. So when I do a git push, thanks Kiran Singh. If you come back to this one, and now let's do a compare between our branch. Now you can see that previously it said that there are no differences, but right now it shows that there is a difference. So any number of commits, we can do it. We have a full free hand, but think logically. Whatever you are checking in should be logical step. That means imagine a scenario you're working in this program itself, where you did some changes in the data layer, where you have entities, and then you did some changes in the business logic layer, and then you did some changes in the configuration, and you did a commit. You can do it. No one is stopping you. But imagine a scenario you did something to this repositories and data transfer objects. Do that as a commit. Now then you went to the persistence layer where you wanted to change something in the DB context, maybe you added something in the modeling. Do that as a second commit. Then you did some changes in the business logic layer. Do that as part of the commit. Why? Because when someone is reviewing your code, it will be very easy for them to see that what happened in that particular commit. Like if I see this one in this particular, okay, this is a merge one, I'm sorry. If I go to that previous commit before merge, we'll see that in a minute. Here, if you see that, it clearly shows that what is that I did it. Oh, I changed this app to school app, and here I did a couple of changes. Here I did a couple of changes. And that is the reason, create a logical grouping. Like all these three changes were related to the code deploy, the changes what I did it here. Now here, if you see that the test one, this change is for the demo. Now whoever is reviewing your code before approving your pull request, it will be easy for them to know that what changes went in which commit. It will be easy for them to review the code. Now let's come back to the pull request and we can click on all pull requests. You can see that there are a couple of pull requests went in yesterday. So 18 hours, 13 hours, last pull request was 10 hours ago. So now again, I'm creating a pull request. The source is always, it should be the feature branch, and destination should always be the dev branch. I mean, I'm using the main branch, but the lowest environment is dev integration. Now click on compare. Now it does a compare. It says that all is well, and it shows the number of files and number of commits. Please ensure that you're reviewing all these things, because I use the same branch name. It is carrying all the commits which I did since past 18 hours. Generally, we do it per work item or whatever the work which we are doing. Always it should represent the task ID. One of the way I do it is my name, the task ID, task description. Like this task ID could be either the user story or the product backlog item or the task or the bug ID, but it should be ID hyphen task. Everything lowercase, do not use uppercase. This is, I follow that. I don't want to enforce anyone on that, but I'm just telling what I follow. Now, if you see that I didn't have approvals and other things, we'll come back in the month of March or April to see some of the notifications and other things. But currently my focus is covering code commit, code build, and code deploy, then code pipeline, then the notification using SNS and other things. Then we'll come back and do different microservices and ECR, ECS, and EKS. Will do a lot. Now, because this is my code, technically there should be approvals and code reviews, but I'm bypassing everything just for the demo sake. And God, now I'm not deleting the source branch because we will raise one more thing. Now we can come back to the pull request. Now let's go back to all pull requests. We see that just now we created a pull request. So that's about the code commit. Now let's come back to the code deploy. Now, sorry, code build. I'm sorry for that. What is this code build? Now, similarly, before jumping to the code build, we were there on the right track. I'm sorry for that. So we need a couple of roles. I'll come in here and code deploy. You can see that there are two roles. One is the role which is needed for EC2, and one is the code deploy service role. The code deploy service role is pretty simple, and it has got AWS Code Deploy, and that itself has got all the permissions, whatever it is needed. You can see it can go and talk to the EC2, having the elastic load balance and resource group tagging and SNS the notification. Okay, so the one which is for the EC2 is little tricky, which it's not tricky. The thing is very simple. It needs the AWS Code Deploy for EC2. Why? Because the artifacts will be stored in the S3. So it needs to access that S3. So it needs to access that. And here we said resource star means any of the resources go and can access this. Those are the two things. That's the catch. It took some time, maybe 3 hours. I scratched my head to figure it out. Now, if you come back to S3, now let's go to the buckets. We first need to create this one, AWS CI/CD demos. And inside that, yesterday I created this school API builds. Inside this, all our builds, whatever we'll be doing, will get stored. So we can see that as of now, we have 2 of this one. So that's the first point. We need the S3 bucket And the next thing is we need to create a code build project. Now let's come back and see that what is this code build project. We have seen the AWS Code Commit, and we have seen the IAM roles, what is needed, the code deploy service role, and EC2 code deploy role. EC2 code deploy role is little tricky because we need to ensure that this has got all the access. Some other service, limited service, it doesn't do. I tried it. I had to scratch my head for 3 hours before realizing that it's not able to access it. If time permits, I'll show you how many times I failed it. Then we have seen this. Now come back to the build projects. Now within the same code developer tool itself, you can see the build projects. The build projects is this one of this which we created. This is where we will build it. Okay. Now this shows the build history. First time I failed it, this is nothing. I'll show the other places it failed more than 25 times. That is fun part. I have to definitely show you that. Let's go to this applications, and this is the sample API, and let's come to the deployment. As I was mentioning, this all is bloodshed. So I didn't realize maybe 20-25 times I failed it when I was trying it on 30th Jan. Then I realized that it's unable to access it. So that's when I figured it out that it needs. Anyways, it's a good lesson. No, I'll not forget it. So coming back to build details. So if you see that build details, it definitely asks for the source. And what we can do is just we can quickly walk through instead of creating. So we can give some name, and the configuration we can do, and even we can have the build badges, whether the build has been failed or passed. And then you can see, you can get the source from AWS S3 or Code Commit or GitHub, Bitbucket or GitHub Enterprises. And we can select the repository name. Which one do you want to use it? We can select that. And it asks the branch. I'm going to select do it from the main branch. Technically, it will be the dev branch. From now onwards, I'll use main, but the lowest level will be dev. Always it should be. And inside this one, we'll use one. It says full, but the latest one should be good enough. I'm taking one, the top one. Provisioning is on demand. And environment is managed. If you have a custom Docker image, you can use it, but I'm sticking to the game plan of using the AWS one. Compute is EC2, and operating system, whatever the kind of operating system you wanted, I always choose Ubuntu. And here standard, and the image is this one, because this is very, very critical, folks. Because what happens is the AWS Code Build standard. If you see that AWS Code Build standard versions. Now, if you see that here, they clearly define like what is your operating system, what is that you have to choose it. So based on that, I have kept it somewhere. I don't remember, but I will tag that log over here. Okay, so yes, I think this is the one, available runtimes. Now in this available runtimes, it is very, very important that you see that if you want to use a .NET 6, if you want to use .NET 6, you can use Ubuntu standard or Amazon Linux standard 3 or standard. These are the standards. Now I want to use .NET 8. So definitely have to stick to the Ubuntu standard 7.0. If not, things will not work. Here, if I select 5 or 6, it will not work because the supported runtime, I want the .NET runtime .NET 8. So definitely it is. I need to use Ubuntu standard. If it is Amazon Linux, I can go ahead with this one, ARC64 standard 3. If it is x86 64, I need to stick to 5. If it is Golang also, you need to check what is supported in Java. Please, I'll keep this. So that's one catch. You need to do it when you're choosing it. And the service role is it's creating a new service, or we can select any of the existing services. So timeouts we can modify. And another important thing is, if you see, switch to the editor, this is how it will be. The spec file. We'll come back to the spec file. Everything is ready for us. So environment variables, we can inject the batches and phases, install and pre-build, build commands, post-build, reports, and artifacts. So we will have install phases and the artifacts. We can do caching also to speed up the process, but sometimes it's a double-edged sword. Sometimes it troubles us. So my personal choice, I don't use it. And then artifacts. Artifacts is you can store the output of this code build to a Amazon S3, where we can go ahead and select the buckets, and then we can specify the path and the packaging. How do you want to package everything in zip package? And logs, we can push the logs to CloudWatch. Okay, the catch is very, very important catch is that when you're choosing it, please ensure that you go refer the documentation. What is your runtime requirement? Based on that, you need to choose it. Okay, now that we did a little bit of dive, if not deep dive, somewhere we did a dive. Now we can come and select the school app. Now we saw this one, and quickly we can see the build details. So this one we have seen, and here it is EC2 and VPC environment. We don't need it. Spec file, we'll see that. Artifacts, we saw this is the location. Packaging is zip kind, and logs, we are sending it to this one. And triggers we are not using. We'll come back to the triggers and metrics, but at least you can see that build history is the one which you can see that. Did we start the build? No, we didn't. I think so. Now we'll come back to the build spec file. So what is this build spec file is? It gives us it gives a decent chance for us to go ahead and customize. Now if you see that runtime, we need .NET 8, so we are installing that. And pre-build, I'm not doing anything. Now the build, I'm echoing at what time the build has started. Technically, I should have echoed at line 18 also. When did it complete? At least I'll know that, how much time it took it. Now restore, build, and publish. So these commands, what we have to do is, we need to test it in our local before we push that to the repo. Now see this, wherever is the build spec, that's the context. So right now I'm saying that .NET restore school app SLN, because this build spec is at the level of the SLN. So I'm using dot. Suppose if this school app is inside this folder, at that time I'll use dot the folder name dot the SLN. If you go back and see the other one, I'll show you the difference. But please ensure that the context is where is the build spec. From there, where is SLN file? That's very, very important. Now the next command you need to execute, .NET build. It is building it. And this one is publish. So we are publishing the packages. Now the binaries in the release mode. Now what is it happening is it published it to the target. So in future, we will be seeing this target at many different places, like target here, at different places. Now, what is this target? This target is nothing but the output folder name, which we have defined inside the build spec. So if you see this build spec, these are the connecting dots. I'm specifically giving you the connecting dots. See that? We're saying target. We're saying target in appspec. At different places, we'll use target. Don't confuse. The target is the output directory. If you use publish, then you need to use publish at all those places. That's very important. Okay. And these are some of the scripts. We'll come back to that. Let's not derail it. So you can see that this is a build spec file. Now we need to build the repo. Let's go back and quickly build. Let's start the build. Let's go to the build history. What was the last build? It was 53 seconds, 10 hours ago. And if you copy the build batch, and you can put it in any of your MD files in the repo. So if someone wants to try, they will know based on this badge whether they need to download the repository or is it safe. At least if it is failing, the users knows that it is failing. So the build batch is very, very important, right? So now let's go and hit the road. You can see that there are different phases. Now submitted, queue, provisioning, and download the service. You can see that build logs over here. And it will not take much time. It is downloading the sources. That's done. Now install phase, because we need to install the .NET SDK. You can see that .NET 6 SDK has been downloaded successfully. Now it's downloading .NET 8. Maybe I missed, but it's downloading .NET 8, and then it is running the build command, and the build was succeeded. Then it published it. It published it to the target folder, and all is well. So you can see that it pushed to the artifact directory. What all the things it pushed? Target, all the binaries within that target folder. You can see that the target folder has got all the binaries. So that it pushed. And the next thing, appspec.yml, that means it pushed this one. And next thing it pushed is script, everything within this scripts folder, right? So now what we can do is come back to the S3 bucket. We had only these two things, A14D, 47.4a. So A14D, 47.4a, you see this, it has been created just now. We see the timestamp 5th January 9:52. That means a minute ago. And if I come back to this one, I can click on download, and that guy will get downloaded. Okay, so that's school app zip one. Now if I go in, I can see the target. Technically, it's a published folder. And we see the scripts and we see the appspec file. So that's cool. So that's the one. Artifacts we need to verify. Now we need to prepare the EC2 instance for the code deploy. So for that, if you see that, I have created a EC2 instance, and I will save it here so that it will be easy for me to spun. This is an EC2 instance. It's all running. Let me connect to this. And I'm using the EC2 instance connect. I'm not using the SSH or SCP. Different tools are there. Putty. A lot of tools are there, but I'm not using anything. I'm just straight away, I'm coming to this one. Clear host name. We can see that it gives the public IP. And if I do ls-hell, it has got all these things. ls-hell dot school app, all the binaries which are there is here. But as I was mentioning, these two roles, that's the catch. The EC2 is a catch, ensure that that has got access to S3. Now we need to create an instance. We created. And the first thing is we'll deploy code deploy. I mean, whatever the commands which has been shown, technically you can inject that while creating the EC2 instance as part of the user data. So I did manually. So I wanted to go the hard path first before doing this heavy lifting from the automation perspective. Just drop these commands inside the user data that gets processed. It's simple, but I need to know that what is that which is involved. So you need to install Ruby and wget and then get this one. And a lot of places they confuse. I got confused. I don't want to say they confused, but I got confused because how do you generate this link? Where do we find something like that? So if you see this code deploy reference kit, and inside the reference kit, this is the one which defines it. Now I executed this command, AWS Code Deploy US West. This is the S3, but how do you know that in which area it is there? This link, I'll add this link also. So this is the one I've used at the West US region, right? US West 2. So US West 2. So they clearly say that the bucket replacement, when you wanted to deploy the code deploy, so you want to use a different regions, the bucket name should be this one. You can see that AWS Code Deploy US West 2. AWS Code Deploy US West 2. That's the catch. Okay. And that's it. That's a simple thing. You can see that. So this is another link which I have to give. I will put it here. So I had to struggle for 30 minutes there to find out who stores it, how. So then I came across this link. It clearly shows that what should be the bucket replacement. You need to replace this piece. That's it. Okay. So that installs the code deploy. And now we need .NET 8 runtime. Now .NET 8 runtime, again, the commands, I went to Microsoft site. That's an action item on me. I will give that links also. I'll update this. So, it's a straight lift from Microsoft site. These three commands, execute it, and then this one command. And then if I do .NET info, it doesn't install any of the SDKs. If you can see that, no SDKs were found, but we have the runtime. So you can see .NET info. You see that? No SDKs, but the runtimes are installed. And the next thing is AWS Code Deploy. Now let's come back to the final phase. Is this one. Let's come back to Code Deploy. There are three important objects here. First one is the application. This is school API. I created 10 hours ago. And within this, we need to create a deployment group. Okay. I see this deployment group like to which environment you're deploying. Like, is it like to dev or to test environment or to stage environment or to prod environment? So we will go to that deployment group. Okay, deployment group. Here, if you can see that, I'm deploying to EC2 Code Deploy 002. That is this guy, this virtual machine. I mean, I'm from Azure side of the world. Since 3 years, I'm learning AWS also. So easy to apologize if I say virtual machine. And these are the set of deployments. Okay. Now, how do you deploy? This is the good thing, the catch. This is nothing catch, but understand that. So see this. These are the latest binaries. We saw that. We saw the timestamp also, isn't it? for this one. Let me go back here. The timestamp is 5th January 9:52, right? So let me click on this. This is a zip file. Now I need to copy the S3. Now I'll come back to this one, and we need to create a deployment. And before creating the deployment, let me come back over here and do a HTTP on that public IP. When I do that public IP, why did it refuse? Just a minute. Let's see whether the service is up and running. I mean, everything will be automatically done because just that I stopped this instance last night and I started this morning. I just want to check the status of that. Okay, that's the reason. Just a moment. Now let's do the status. Now it is up and running. Now let's come and check this. It is giving the output. And now if I say API, it gives the output. Okay. So I stopped it. So I didn't put it as part of the process where every time the machine reboots, it should start. And I did this session back 2 years ago. I'll put that link also so that you'll find extra details. It's there somewhere in the YouTube channel also. If you go and see the playlist of AWS, and somewhere here, I think somewhere here I did it. Maybe most probably this is the one, but I'll find out and I'll drop the link over here. It gives much information on this one. Okay, so now that we understood, we are able to hit it. So I just wanted to ensure that before deploying, are we able to hit it? Okay, so now let's come back to S3 and let's copy this, come back to the AWS Code Deploy. Now within the deployment group, we are doing the latest deployment to the dev environment. I mean, even though it is main, I have only one. So the deployment group is this one. It's going to deploy to EC2, and my application is stored in Amazon S3, or it could be at the GitHub also, the binaries. Now you have to give this link where you'll get it. Go to that file, particular file name, and click on that. And then in the next, specify that it's a zip type, right? And we can give the notes, live demo, hope it will not fail, a winking face. And don't fail the deployment to an instance if the lifecycle event fails. I mean, and I'm not doing any deployment override or rollback, and I'm clicking on create deployment. So you can see that it does the deployment, installing the application on your instances. There you go, it succeeded. Now you can come and view this, and you see that application it stopped it. It downloaded the bundle. Before install, after install, application start, validate the service. So we can come back here, and what we will do is we'll get the service. So just to ensure that it is working, we will go to the instance 002. Here we have the FQDN. This time, let's use the FQDN. Okay, there you go. So one more thing what we can do here is we can also verify the logs like this. If I do the status, the same command we executed previously. Yeah, this is a command. So you can see that. And I can come in to /API. It's giving /API/ courses. It is spinning and it is giving an empty array. Okay. So the empty array means, I'll show you the catch. See this, we did a get to API courses. So it is giving us. Why didn't it not give us the data? If you go to the HTTP pipeline configuration, I am creating the dummy or the seed data only if it is the mode is development. Now we have deployed the service. Now the mode will not be in development mode. It will be starting in the production mode. So that's the reason it didn't execute the seed data. If not, we would have seen the things. Okay. So I think I focused more on connecting the dots because I was trying this since a couple of weeks. So wherever the problems I faced it, I collected and I'm specifically giving those information. So what is next? Next, we will focus on the AWS pipeline. And thanks for joining. Hope you guys have learned something new in this session. Please subscribe to the YouTube channel, also to the meetup group if you haven't. And I'll update the deck. The source code is already up to date, I assume. If not, I'll see that. And thank you so much. And you have a good rest of the day.